All right, so today's lesson is on multiplying radicals. Okay, you do have a ditto to do for homework, so just make sure that that gets done. Okay, so last lesson we talked about adding and subtracting radicals. All right, multiplying radicals you might find to be easier, but I mean really they're kind of equally as difficult. It's just that with adding and subtracting radicals, you have to have like radicals, right? So in the last lesson, we practiced breaking down any radicals that needed to be broken down. And then once we had those like radicals, we could go ahead and add or subtract the numbers that were in front. Well, multiplying radicals is kind of the opposite. With multiplying radicals, we do not need like radicals. We do the multiplying first, and then once we get an answer to the multiplying, sometimes that answer may need to be simplified. Okay, so it's a little bit different, but it uses the same skills. All right, so here in the steps, it says step 1, you're going to multiply the coefficients. So whatever those numbers are in front of your radical or radicals, you're going to go ahead and multiply them. Then you are going to multiply your radicands, which remember are the numbers under your radical. Okay. Then, if necessary, you're going to simplify whatever radical you got as a result. Okay, so it's not too bad. All right, so let's start taking a look at a basic one. So for instance here, in number 1, it says find each product, write your answer in simplest radical form. Now remember, this square root of 8 here, or this radical 8, that really technically is a 1 radical 8. So when step 1 says multiply the coefficients, we're going to do a 1 times a negative 3, which will give us negative 3 in the front. Then we're going to multiply the radicands, what's under my square root. And 8 times 2 is 16. Now, at this point, several things could happen. You could get to this point and say, okay, well, I can't simplify anything. That's it. I'm done. Or you could get to this point and say, all right, well, let's look at what's under my radical. It could be a perfect square, and you can simplify that way. Or it could not be a perfect square, but it could be something that can still be simplified. So here at this point, I look at what's under my perfect square, and I have 16. And immediately I notice, oh, well, 16, that's a perfect square. So I'm going to keep that negative 3 in the front. The square root of 16 is 4, so this is really going to be negative 3 times 4, which is going to actually give me negative 12 as my actual final answer. So the square root actually wound up completely disappearing in this particular question. It doesn't always happen that way, but it did for this one. Okay? So let's take a look at another one. Let's work our way down. So let's take a look at number 3. All right, so again, we start by multiplying the coefficients in front. So we have a 5 and a negative 7. 5 times negative 7 is negative 35. Then we multiply our radicands. 10 times 12, that's going to be 120. Okay, so the actual multiplication is over. Now at this point, again, one of 3 things will happen. You either say, okay, I cannot simplify this any further, that's it, I'm done. You could have a perfect square under the radical, like we did in the last problem. Or you could have what we have here. And we have a radical that can be simplified further, like we talked about in our last lesson. So again, I'm going to bring down my negative 35 in front. And now I'm going to break this square root of 120 into 2 radicals. So I am thinking to myself, what is the biggest perfect square that would go into 120? So again, take a minute, stop and think. Biggest perfect square that would go into 120 would be 4. And it goes in 30 times. So now remember, we have this negative 35 in front. That is really times the square root of 4, which is 2. And that radical is coming along for the ride. So only thing left for me to do is this multiplication here in the front. So negative 35 times 2 is going to give me a negative 70, and that square root comes along for the ride. And there is your simplified answer to that multiplication problem. Now, they can do this with variables as well. So if you take a look at number 5 here. First of all, remember that this n is to the first power, okay? And I'm going to take the same approach. This second radical, that square root of 6n, that's really a 1 as the coefficient in front, okay? So first we're going to multiply the coefficients. 4 times 1 is 4. Then I'm going to multiply my radicands. So underneath that radical, 6 times 6 is 36. N squared times n. If we remember from our last unit, our product rule, when we multiply, we add our exponents. So that's going to be an n to the third. And now I'm going to have to try to break down this radical. Okay, so the actual multiplication is done, but now I'm working on simplifying. Okay, so again, we've got the 4 in front, and now I'm breaking down this radical. Perfect squares, non-perfect squares. Well, 36 itself, that is a perfect square, so that's going to hang here in the front. And now n to the third. Remember, we want to see even exponents. 3 is not even. So the closest even number to 3, without going over, that's going to be an n squared. But I needed an n cubed, so I need one more n to go in the leftovers. So now I take the square root of what I can take the square root of. So this 4 will come down times the square root of 36 is 6. Remember, when we take the square root of the variables, we just cut that exponent in half. So half of 2 is 1. And then that lonely radical over there is going to come along for the ride. And now all that's left to do is to do the actual multiplication in the front here. So 4 times 6n, that's going to give us 24n, and bring along my radical. And there's your final simplified answer. Okay, so again, it's really just combining all of the skills that we had. All right, so I'll do one more of these, and then we're going to take a look at something a little bit different on the back. All right, so number 7. All right, again, we're going to multiply the coefficients in front. Again, we see that this is really a 1 in the front here. So 2 times 1 is 2. Now multiply the radicands. 15 times 3 is 45. And again, for the variables, when we multiply, we add those exponents. So that's going to be a w to the 7th. So now I'm going to bring down that 2, and I'm going to break down perfect squares, non-perfect squares. So now I have to think to myself, what is the biggest perfect square that would go into 45? That is going to be 9. And 9 goes into 45 5 times. For my variables, again, we want to see even exponents. 7's not even. So the closest even number for my exponent without going over, that's going to be a 6. So we have w to the 6th. And we have one more w that we need to get us up to 7. So now we're going to bring down that 2 in front, multiply it by the square root of my radical here. So the square root of 9 is 3. When we take the square root of w to the 6th, again, we're just going to cut that exponent in half. So that's going to become w to the 3rd. And then just bring down that radical. And now all I can do is do that multiplication in the front. So we've got 2 times a 3w, so that's going to make it 6w cubed, and bring along my radical. Okay, it is going to take a little practice. Honestly, probably the hardest part of any of these questions is probably being able to figure out what that biggest perfect square is. So you're going to want to use your calculator to help you out. Okay, now if we flip to the back, they can also throw distribution into the mix. Okay, so we have two different types of distribution that I'll go through here for you. Okay, remember the distributive property. Okay, that means you're multiplying through parentheses, but it really is still just multiplication. That's all it is. All right, so first we could have single distribution. So here in the first example, we just have the square root of 6, which is going to be distributed through the parentheses. So the square root of 6 times 3, well, notice the 6 is under a square root, but the 3 is not. So that is just going to be 3 square root of 6. We can't actually do any radical rules there. Plus, and then we have the square root of 6 times the square root of 8. They are both under radicals. They are both radicands. So we're going to keep that radical, and 6 times 8, that would become 48. So again, the multiplication is now finished, but you have to check out these radicals and see, can I simplify any further so that I could combine anything? Because notice this is an addition problem at this point. So I take a look at the 6 and I notice, nope, 6 doesn't break down. It's not a perfect square. There's no perfect square that goes into it. But I can break down the 48. So I am going to bring down that 3 square root of 6 plus, and now I want to know what is the biggest perfect square that would go into 48. And again, it's going to take some practice, some thinking, and some playing around on your calculator. The biggest perfect square that goes into 48 would be 16, and it goes in 3 times. So now 16, that's a perfect square, so I actually can take the square root of that. So we're going to have 3 square root of 6 plus, and now this will be 4 square root of 3. And now at this point, well, I'm actually finished because I simplified what I could simplify, but notice even after simplifying, these still aren't like radicals. One has a square root of 6, the other has a square root of 3. They're not like radicals. I cannot add them together. So that's it. That would be my answer, and I cannot do any better than that. Now, in the second example, right next to that, we have double distribution, or sometimes people refer to it as FOIL. All right, we had earlier in the year been calling this double distribution. Okay, so for a problem like this, first we are going to have the 4 get multiplied through, just like we did in our last question. Okay, so 4 times 2 will be 8. 4 times a negative radical 3. Again, one's a radical, one's not. So that is going to be negative 4 square root of 3. You can't actually do anything with the numbers because one's under a radical, the other one's not. So we're just pairing them together as multiplication. Okay, now I have to do my second round of distribution with the radical 3. So square root of 3 times 2, that's going to be 2 square root of 3. Again, got to keep them both because one's a radical, one's not. And then we have square root of 3 times negative square root of 3. Now, careful, because we are multiplying here. So negative times positive is negative. And again, these are both radicals, so we're going to keep the radical. And 3 times 3 is 9. Now I'm going to try to clean this up as best I can. So, first off, I notice that 9 is a perfect square. So, I'm going to bring down this 8 here. The square root of 9 is 3, so we have minus 3. And now here in the middle, notice those are like radicals this time. They both have a square root of 3. So I am going to keep that like radical of square root of 3, and negative 4 plus 2 will be negative 2. Now I'm almost there. My radicals are cleaned up, but I do have a constant here and here. Those can get combined. 8 minus 3 is going to give us 5, so this will be 5 minus 2 radical 3. So again, even though both of these problems looked different from each other and also from the problems we did on the front page, it's still multiplication rules. Okay, it was all the same rules. And then once the multiplication was over, we were just using our addition and subtraction rules like we had learned in our last lesson. So it's just basically combining everything we were learning together. Okay, so again, this is going to take some practice. Try some of the other questions on your own, and the answer key is posted on Google Classroom. Okay, that's it for this lesson, and I'll see you next time.